Welcome to episode 17 of Roid Rage. We have back to a 4-person podcast this time, so my apologies for the amount of disarray this is about to get into. But before we get there, we have a really special guest. We have Colin with us. Colin is our principal engineer. I'm going to let him define what that is and tell you a little bit more about himself.
Well, principal engineer just means that you're a Swiss Army knife.
Okay.
Right. And one of the blades in this thing is comm,
Okay.
which is why I'm here today. I do other things too, but somehow I got into the comm business a long time ago, and it just follows me around. It sticks like goo, You can't get past it.
Colin, you're also like a very different engineer than we normally have at the company. I mean, you are our 4th employee, I think, when we start, right? It was at 4 or 5.
Yeah.
Very early when we were at the 2 offices ago, right? So you've already moved twice as a company.
That's right.
And you had an entire career before this.
Oh, yeah. Yeah, I started on shuttle, okay, believe it or not, STS-1. Even before that, I came out of a department store right into the shuttle program. That was quite a trip. It really made me, I was selling ties.
We literally have people working for us that the space shuttle is the same as dinosaurs.
I know it is, but you know what? I can still fold a shirt like crazy, okay? And I can count change at the end of the day if you need that service, okay? I still got that. But,
so you worked on STS-1?
Yeah, I worked before STS-1 there, yeah. My longest term wife married her, got her out of tile. Okay, she was pasting tile on the forward section of the shuttle. And I'm walking through the OPF one day looking for somebody to go to lunch with, and there she was, all right.
Well, that's a good qualifier.
You're here.
You're here. Yeah.
Location matters.
That's right. So
you're qualified enough to put tiles on. So
yeah. She can really stick to you.
Oh my! You've been using that shtick a long time. That just rolled off way too easy.
Well, don't.
I'm insulated against those kinds of dad jokes.
Oh yeah. Well, you can take the heat though, probably.
Yeah.
All right. So that being said, wandered around quite a bit. But what happened is I was studying comm.
Okay.
When I got picked up for operations.
Okay.
Digital comm a long time ago, and it's proved like the groundwork for all the satellite communications. QPSK, PSK, and everything like that. I was just doing it because I liked it. I'd been an amateur radio operator when I was younger, and I have been doing a lot of things. I've done ground. I've done some gateways. I've done some operations. I've done mission assurance. I've done electronics. I've done GNC, flight software, you name it. It's been a long time and a long road. And basically, the bottom line is you just do whatever is available in front of you that you think you can halfway do, so to speak. So I've been on programs like Shuttle. I was on the International Space Station, God help me. And then I was on, God help me, a second time, I was on EELV, which was a complete damn mess, I tell you.
What was EELV?
Yeah, that was the Evolved Expendable Launch Vehicle, which was a follow-on to Shuttle in terms of its engines, but it was also Delta IV. It's known as Delta IV. It was a commercial version.
There was one in between that it like morphed from, right?
Delta II, I was on that one.
No. The
Delta 3?
Advanced Launch System or whatever was
ALS.
like they renamed it.
It's a terrible name for a rocket, ALS.
They had Delta III, which was a complete failure.
Yeah.
That was a travesty.
That's a bummer.
Right. But
But
I liked Delta. It was a big family there, and I got that's
Delta II was kind of awesome.
It was, yeah.
It's one of the most reliable rockets until Falcon, right? And Delta 3 still kind of lives on. I mean, the top of Delta 4 is a Delta 3, right?
It's
the same stage 2.
Yeah.
But Delta IV is dead now.
Yeah, but I got out of rockets after the ELV program. We had kind of I don't want to go into it too much because I'll probably get thrown in jail, but
well, that's exactly the next topic.
I was like, you shouldn't have put that bait out there because someone's going to take it.
All right, but anyway, so it was so bad that they decided to hide me. So they hid me in Phantom Works,
okay,
where I started to do all kinds of projects, and comm came back into it.
Yep.
What were you working on at Phantom Works?
Well, a lot of defensive counter space, a little bit of NRO comm, which is as far as we can go there. But that was really formative, maybe about probably maybe 50 or 60 short-term studies, 45.
Were you working at Phantom Works out in the middle of the desert?
No, I was working at Phantom Works, commuting between St. Louis, the McDonnell Douglas place there, and El Segundo, pretty much, doing those kinds of work. And down here, and matter of fact,
Yeah.
one of the interesting things is I'm sitting on top of the laboratory that I had when I worked for that company, Boeing, Rockwell. Right. This exact building is on exactly the dirt where my lab was. Okay.
And we demolished it and built this building. And it's way
And
better.
You don't think I don't feel weird driving in here in the morning?
That was my next question, like weird deja vu?
Yeah, I don't know where I am sometimes, but that's not anything to do with deja vu. That's just the way I am. So, but anyway, I got that experience that I got when I was in school just kind of like followed me around because
Yep.
I think the problem is that there aren't enough field comm engineers
There
in
aren't.
the world to fill the need, right?
And like, what's the simple definition of a field comm engineer? Like, help people understand who this person is and why we don't have enough of them.
Well,
All four of our listeners.
There's two flavors. There's the exciting engineer
Hopefully one's
that
a
gets
comm
to go
engineer.
to school and actually build radios.
Yep.
He's usually involved in something like cellular systems, or very complicated types of RF SIGINT or that sort of thing. And then the field engineer is the way I like to look at it. He's the guy that climbs the telephone pole, okay, and puts up the antennas and strings the wires and stuff, right? And that's kind of where the skill is really in demand here, because a lot of what the deep space comm world, which we'll talk about in a minute, is it's a lot of field engineering. You have to go to the sites
Yep.
where they have the big antennas, and you have to take your radio with you, and you have to put it through its paces,
Yep.
pretty much. So that requires more of a knowledge about power and RF antennas, as opposed to designing complex waveforms.
Yep.
Which, I've been around that, but that's a different skill altogether.
Yep.
More of a software-ish type of skill these days,
Okay.
as it is. But, we're the kind of engineer I am you find at ground stations more than anything. They soak up a lot of those guys, but the other end of it, it's a spacecraft where you're trying to get power to the ground, basically, is the description of
Yep.
of the whole career. And vice versa, it's not so hard to get the power up from the ground because that's where you have the big antenna,
Yep.
right? But the spacecraft is hampered because it's light, it's small, it's power challenged. You have a very small antenna. You can't put nearly the amplification on there that you can afford it because you can't afford the power,
Yep.
et cetera. So you're always at the bloody edge of just not quite making it, and we call that link margin, all right?
Yep.
And that's really the hard thing about deep space comm is you're always so far away with such a light spacecraft with so little power, and such a small antenna
Yep.
that, it's just a challenge to get anything at all. So what that translates into is very low data rates and very sophisticated coding schemes.
Yep.
And that's one of the things I studied in school. I have a book this thick on coding. And that's kind of engineer that I am.
Okay.
Right? And it's always been so, like trying not to tromp onto the government too much, but a lot of the challenges.
Well, that would be a first in this podcast.
At this point, they're not going to put you in jail, so you could say it all.
Yeah.
I don't think I can. But that job was pretty much of having objects in very odd places, at very distant places, trying to get a lot of signal through
Yep.
with a very challenged link, okay? And then to get that data down to the ground, and so did a lot of link budgets,
Okay.
So to speak. And link budget is a spreadsheet. The nice thing about this kind of comm engineering is you don't have to have good math. You just have to be able to add because it's kind of like accounting. You turn everything into decibels, which are logarithms, and everything just adds and subtracts. So it's remarkably good for spreadsheets, which is, I got pretty good at spreadsheets, so to speak.
Okay.
Yeah.
Well, so before we get into this, I'm going to ask the obvious question. You've asked God for help at least twice. To my knowledge, you're married, so you're not in search of a wife. How'd you end up here?
I've got a good wife. Okay.
Yeah, great wife. She's lovely.
I'm restless.
Okay.
And I got bored.
Okay.
Okay. And so, I was running the so-called, I'm going to do air quotes, consulting business,
Yep.
which all old farts do, but it's mainly to be able to pretend you're a business and get into some of these institutions and things like that,
I feel totally called out.
So we have the no consultant rule.
So I'd done about 5 programs,
Okay.
with people that didn't pay me,
Yep.
but usually they ended up in a paper or something, right? And that was fun. A recruiter called me and said, basically, I have a job in Huntington Beach. Well, nightmares of traveling to El Segundo every day are still with me. I'm saying, okay, well, I'm interested. It's Huntington Beach. What is it, Home Depot or what? No, she says there's this company called AstroForge. And I figured, okay, Astro and Forge, they must be going for asteroids. And that's what it turned out to be.
Told you the name worked. Just to be clear, that's why it's the name. Simple and basic.
Way better than the
So I
podcast
called
name.
them up and, kind of as a jokey sort of thing. What are you guys, and everything. They called me down to their nice little beachside office, which really charmed me. I like that. Mother's Market was right nearby.
We should
They had
do all our
Starbucks
interviews down there.
They had everything I needed. Mother's Market, and they had Starbucks. Okay, so I was like 80% there right at that point. So it turns out that, what I have been doing for the latter part of my career was completely unrelated to comm. It was astrodynamics. Okay. And I'd been doing some projects in like locating satellites in odd places and, trying to figure out how far they were and where they were going and stuff like that. So that kind of experience, was just something that with a company of 4 with absolutely nobody that could do any mission planning, I was able to come in here and do that. So that was really a lot of fun to do that, So, and in the meantime, they were struggling with their radios, and finally I kind of I said, okay, I've got to say something. And so I told Matt, I think it was Matt, I said, okay, well, I do comm, I could help you out here. And he said, all right. So the next thing I know, here I am again.
But we didn't hire you via recruiter. So do we owe our recruiter some money? Is that what happened? They reached out and you're like, I'm just gonna call them directly. Because I think you emailed us directly, like a cold email to us.
Well, yeah.
If you're the recruiter, I think that's what a statute of limitations is elapsed. So
We'll send you a T-shirt. Yeah.
We won't talk about that. But no, I was just up for the game, and
we don't edit this at all. This just goes out. We don't have time to edit.
That's why we're not talking about it.
how long when you showed up on day one? How long did you think you were actually going to be employed for?
Well, I told you when I came in that I would do 2 years, or mission 2, whichever came first.
No, that's not what you told me.
Why?
You said, I'll be surprised if this makes it 2 years.
Well, as a retired guy, I wasn't too concerned about that. Okay, what I was more concerned about, is whether it would kill me or not, and it came damn near close. So that's basically, you guys run a hard game here. You run fast, and you're running far. So I knew that was going to be the way it was coming in, but I didn't think it would be so much of it, so to
By the way, I'm thinking of changing the radio again.
Are you?
Yeah, can we run the link margin one more time? Yeah.
Okay, well, I'm going to leave that to a younger guy. Right.
Okay, so we got while you're here. We've talked about comms on this podcast before. I don't think we've ever actually defined what deep space comms are, and you're probably the best qualified person to do so.
Well,
regardless of what Matt's about to say. So why don't you what's the best framing for how to understand deep space comms?
Okay, so what it provides command capability to the spacecraft, telemetry capability from the spacecraft to the ground, and that includes things like imagery as well. But it also applies to tracking and navigation, which is not usually done anywhere other than deep space these days. And we go way back in time to the Apollo era for the type of navigation practices that we have to follow in deep space. If anyone knows what Doppler is, we do an awful lot of that. Okay, we also do some ranging using some sophisticated digital codes to measure the range to the spacecraft, and turn all that into a position and a velocity for the spacecraft. And that's the only way to do it is with the radiometric tracking. The other distinguishing feature of deep space comms is, as I've intimated in my joking around, is that we have really challenged links. The power is very low when it reaches its destination in both directions.
Yep.
And we have more power.
When you say low, what do you give a sense of direction there?
Okay, well, you have to compare numbers. So in the geosynchronous, which are the comm satellites, DirecTV, and all of that, they're about 42,000 kilometers out. Okay, and they usually can get a signal to the ground at a number of minus 110, and that's in dB milliwatts,
Right.
for those of us who know what it is, but minus 110. Okay, and we're talking about, like the seismic scale in earthquakes, this is logarithmic. So every number is 10 times the last number, all right? So remember, that was like 110 was a good number, minus 110, and minus 110 means it's that small below a watt, okay, or a milliwatt in this particular case. So we're talking about, hundreds of thousands of milliwatts below, okay, that threshold, right? So in deep space, that's geosynchronous, all right, hard enough. In deep space, you're talking about power is down at minus 160 to minus 180 dBm, okay? Lucky to be able to pull that out of noise at all, okay? And so one of the other flip sides of comms are noise. You've got to watch that. So the way you basically have to do that is with very very precise signals, very precise clocks, with coding, which, if you're familiar with disk drives or anything else that is error correcting coding, you get like your RAM when you buy it for a computer. It's error correcting code RAM, right? We use exactly the same codes, but on the links. And that allows us to receive the signal and then pull it out of the noise, so to speak. And there's the ground side of that is a lot of commercial equipment that has some fairly sophisticated schemes for demodulating, which is to detect and extract the signal.
Yep.
And so all of that is it's always just on the hairy edge. You never know if you can do it. The only way you can get to a decent signal is to put big antennas on it, which is what is another problem with deep space, is because most of the antennas that we use for space travel and space today, even the ones going to moon, they're small, okay, compared to the ones that we use. You think about a meter is more than a yard long, okay, and a good antenna for us would be about 22 meters, okay. So you're talking about something almost 100 feet across. It's not a trivial thing that you're going to put in your backyard. And,
Except for Peter.
yeah. And
Peter, our Lord and Savior.
And then the best
Thanks
of
again,
these
Peter.
guys, they go to like extreme measures. They will like cool their amplifiers with liquid nitrogen and things like that in order to get the noise down. So it's really like, you're really talking about expensive assets there that you're using. And then the other thing that Robyn will appreciate, is when you're in the low Earth orbit or in geosynchronous, contact doesn't cost that much. You just get on there a couple hours and you're fine, And no, we're going for 8 and 14 hours at a time on extremely expensive assets. Okay, just to be able to get.
Oh, there goes another car.
The other thing to remember here is that we are by far one of the smallest spacecrafts ever sent to deep space. So where you have something like a Voyager, a Juno mission, a Psyche mission, they use very different equipment than us, right? They'll use pointing antennas that provide a lot more gain, and they'll also use traveling wave tubes that can provide about 100 dB of gain. And
You're talking about on the spacecraft.
on the spacecraft, yeah.
Yeah,
We don't, right? We have to stick with patch antennas and solid state amplifiers.
Well,
and
we
it
went
makes
through
it
an
hard.
exercise to find a traveling wave tube, a tweeter, as they called them.
Yeah.
Would have been a very nice amplifier and would have helped her downlink, but
Nope.
the damn thing was too heavy and it cost too much.
It
and
weighs half the
yeah.
spacecraft and it's $1 million, right? Like, what the hell?
And also,
I like that you just casually said a little too heavy, and it's like half our existing mass.
and also not available until
Yeah, summer
your
2030.
your kid's in elementary school or something.
Yeah, something like that. But the good thing though, this is the thing about the company is that we do what we can. Okay, we don't do what we don't wait 10 years to do the science.
Yep.
We do what we can at the time. So everything's very rapid here, which I complained about before, but it's pretty amazing. Okay, the fact that you can make so much progress by being, I wouldn't say compromising, but being practical about what you can get, when you can get it,
Yep.
and how much it weighs, and then just throwing it on there and making it work. This is much different than the spacecraft that I was.
And to be clear, by throwing it on there, you mean perform the necessary finite element analysis and all testing as required by the RIDE the
Well,
rideshare payload user
Yeah,
guide.
that's assuming you can find a person that will do it for you, you know.
When did you get all lawyered up over here?
I know. We hired Crystal. All of a sudden, Robin's got like
Have
this
you-
whole
Have you
docket to
have
read
you
through.
seen the mailbag?
We also found out last episode, Chap, why you proofread them. That's a different point.
Yeah, but like you talk about Voyager, okay, it has a whopping big antenna. I don't remember exact size on it, you know, but
It's a
big
giant, and it's a directional
It's
antenna.
a directional antenna, right? And it points directly at Earth, you know.
Hopefully.
Yeah, but then you go to, this is really deep space when you talk about something like Voyager. You talk about really low data rates, you know, which you have to have custom designed radios to do. They're talking about 5 to 8 bits per second. On
That's
this link.
crazy.
I mean, our bit rate on Vestry, so everybody knows, on the next spacecraft is going to be 100 bits per second.
Yeah, 100.
That
bits.
is extremely slow.
That's very slow too, and we just can't find a radio off the shelf to do anything slower than that. It's hard enough as it is, you know. So the days of $1 billion custom designed radios may still be here for NASA, but not for a company like us. You can't do business that way.
Well, maybe there's one on a canceled program or something.
Well,
We'll go look at
Probably
auction.
about 20.
yeah, but okay. So here's the problem. Okay, I said business on purpose. We're a business. You've got to be able to repeat this process. Right?
Yes.
So you got to be able to do this over and over again.
Yeah, Radio Shack's out of business. Can't
So
go there
you're
to
not
get
gonna be
replacement
buying,
parts.
you know, tweeters that are more expensive than the, you know, what's got to happen is that there got to be enough customers so those tweeters become less expensive. You know, the tweeters are the travel.
Working on it.
Yeah.
Can we talk about the navigation for a second, though?
Yeah.
Navigation, I think, for everybody to understand how it's different than a normal spacecraft, our beam width on some of the large dishes was 0.5 degrees. Like, you
Yeah.
got to be pretty accurate in how you get there. So
Yeah.
how did we get that? I mean, we were actually really successful on this on Odin by being able to find point to space, the antenna at the spacecraft, right? We were able to update its navigation. How do you do that?
Well, filters would be that in a word. The filters are miraculous. They're mathematical beasts that can grab a whole bunch of data and find the correct path through that data. Okay. So basically, we take thousands of measurements at a time, which accounts for the 8-hour contact sometimes. And the measurements are, as I mentioned before, they're Doppler. They're the change in frequency as the spacecraft travels, with a little bit of range, which is how far it is. And you take thousands of these measurements over time that are changing as the spacecraft travels. And the mathematics can actually pull out a position and a velocity for that with some a priori knowledge, because you know how astrodynamics works. Right, we call that D-dynamics. So you have a very good idea of what can happen, okay, to give the filter some truth, okay? So basically what the filter does is it compares what you think the truth is to what the measurements are saying where it is over thousands of measurements, and then comes up with its own estimate of where you are. And that's usually pretty accurate, okay?
What's pretty accurate in deep space?
Well, if you have a really big antenna and you're NASA, it's like 0.1 meter, okay, for a measurement. All right.
Wow.
If you're
That's
us,
how accurate they know where these things
yeah.
are.
That's crazy.
If it's us, it's like maybe 10 meters. Okay.
Which is still pretty good. Like, I mean,
I'll
that's
take
enough
10
to
meters.
avoid a planet.
Yeah, I'll take 10 meters all day long.
Yeah. But it takes a long time to do that in a lot of measurements. And then you know, the best laid plans of mice and men, then you start to wait. You wait. Okay, you've spent your 20 hours and Robyn is beating you on the head because he's out of money. And so like 3 days later is the best you can do for another navigation path, right? Well, that spacecraft has been doing stuff that you didn't predict, you know, and now it's about 1,000 meters away from where you are.
So what causes those errors on the spacecraft?
Well, a very large part of it is our perturbations, okay, that we can't model, such as you can model like, think about, you know where the sun is, you know where the earth is, and you may know where the moon is, okay, but you kind of only don't know where Mars and Jupiter and all the rest of them are. And by the way, the sun is blowing smoke at you the whole time. We call that solar radiation pressure, you know, which is lumpy, you know, as you're going along. And then you've made some errors in your last maneuver, okay, which are propagating out. And the basic bottom line is you have to get a contact to make more measurements before you get too far away from where you think the spacecraft is the next time. And so part of our game and the early point is to do a lot of simulations and try and figure out exactly how long can we wait between these contacts before we can't see the spacecraft anymore. And if that happens to you, which it can, because you can have something come up, then you
like the ground station not working.
like the ground station
Just
not working,
random example.
or somebody else
Pulling that out of a hat.
somebody else stealing your antenna, for that day.
Oh, yeah.
That can happen.
Or the testing getting stuck in the middle of the antenna if that was to happen, or the antenna catching on fire. Not like that would ever happen.
So at that point, you start searching, okay? And if it's not too many days out, you pretty much know which direction to search in, because you know where it was wandering in the past couple of days. It can be a long. We break everything down in terms of ranging in a long track, cross track, sort of thing. And so pretty much you know where the errors have been accumulating, and that's where you think you're going to look, okay? And usually you'll find it, and you get your measurements, and everything will be back on track, And if you're lucky, you're in a very smooth type area of space, which is, far away from the planets and the moon, and you only have to worry about the sun's solar radiation pressure, and that's over time, it's a fairly constant perturbation that you can predict,
So wait a minute. You do all this math in a variety of open source and closed source software, right? Like some of it you've written, some of it we've stitched together from other public domain, and I'm sure there's a sprinkling of NASA code in there. And how do you know that tool actually is going to not lie to you?
Well, that's the scary part, because you don't. All right.
Oh man, new action item. Seriously?
The best way you can do it, okay, is you can compare its results to other missions that have actually flown, okay, and that's exactly the way they validate these tools. The first time you ever bring up, say, a propagator as your classic case, you don't know, all right? So you run it off against other propagators that you trust.
Yep.
Okay?
Which one do we model it to? What missions?
What's that?
What's the missions we model it to?
Well, like another lunar mission would be something similar, right? Okay. We're kind of in a bad place, to find missions that we model for deep space. So what we have to do is we have to model.
Really wishing I had missed this podcast.
I mean,
how's your anxiety level going?
Oh, my anxiety right now is.
Okay, here's a for instance, since we're telling ghost stories. All right.
Oh, no.
Okay, so all the deep space missions travel out to far planets. Do we accept that, right? Okay, we're about the first that kind of like lurks along with Earth, looking at near-Earth asteroids, okay? And we're finding that's a far different navigation problem than flying out to Mars, all right? Because
Is it easier or harder?
harder.
Oh, no.
Why did you
no.
ask, Matt?
God
You
damn.
knew.
Yeah.
He wouldn't have
There's
said.
really only
He
one.
wouldn't have brought it up if it was
'Cause
easier.
I tell you, if you're just flying along with Earth and your antenna's on Earth, you're not moving very fast. And Doppler kind of depends on you moving fast, right?
How fast does Doppler anticipate you moving?
Well, we are traveling within about 1 kilometer per second of the velocity of Earth sometimes, and whereas a deep space probe is going to be looking at maybe 2,000-3,000 kilometers per second of change,
Got
okay, relative to the Earth's velocity. But now you think about it, we just kind of fly out from Earth and say, oh, there's Earth. We'll just fly along with it until we encounter an NEA. Okay, and that's
Sounds
really
like I can offload some propellant.
yeah. Well, I mean, yeah, we could get into propellant. This next mission doesn't look like it uses a lot because it really does just lurk around Earth. So
I got 5 kilometers a second. You're telling me it doesn't use a lot? So wait, how much do we actually need?
hey, do you trust me?
I don't know after this
Well,
conversation.
wait a minute. Wait.
It feels like after a couple of years we're just finding this out. I don't know the answer to that right now.
Yeah, I think I'm going to need some further interrogation on that front.
Yeah, so it's that's why I love this area. It's really it always presents you some new problem. But anyway, getting back to the original question, so we can
Good
compare-
luck.
The systems we're using are known to work very well out to the moon. Okay, and beyond that, they really haven't been tried that much. Okay, so you have to extrapolate. Okay, pretty much. What's going to happen is that the measurements are going to tell us how good our system is.
Yep.
All right. So we're going to be making a lot of measurements in the first part of the mission and get satisfied that
Ka-ching, ka-ching,
our truth is
ka-ching.
telling us. Now, that being said, we on our last mission, we were able to, we get a set of numbers from the launch provider when they drop us off called an OPM, which is an orbit something message and a propagation message. And we were able to take that message and use our system to accurately predict the position of our spacecraft all the way out past the
Yeah, you guys are money, man.
Yeah. I mean, so we have a lot of confidence in that propagator at this particular point. If we can do that, then we should be pretty good, I think. You know, and the orbit determination system is old. It's been around for a long time. It's done a lot of missions. Okay, the filters. You talk about Swiss Army knife helms here, but no, that thing has a tool for just about everything. You know, and the scientists at the AGI company are always thinking about the next, problem. For instance, they're really working hard on these types of electric propulsion missions that we're flying now, and making some good headway on that. So I have a lot of experience. I don't think we could buy or get another better tool than that.
Okay,
to do the mission analysis.
I don't have any money for another tool anyway.
So, but I'm saying that because it's costing you an arm and a leg, and I want you to keep buying the service support package for us. Okay.
I feel like this entire podcast was the setup.
Sales call.
Well played.
Wow.
We're 35 minutes into the point that he just wanted to drive home,
Yeah.
which is like, hey, I still need that software package.
I bet that PO is being sent to me right now.
It's next level. Hey, how much harder is so this next mission? We're going to EP thrusters. It'll be much more continuous thrust as opposed to the chemical propulsion, which is instantaneous.
Yeah.
How much harder is it?
We're doing some work that actually seems to indicate it's easier to plan. Okay, now to fly, I'm not so sure yet. Okay, my experience with Hall effect thrusters is they're nasty beasts. They're always flaming out. They take hours to get started again. They don't do what you want them to do. And they wear out. Okay, so we
got any proof of this? Like, holy shit! What do we got to go look at?
When you see absent at the design review,
Someone hates EP thrusters. What do they do to you?
Which is exactly why, at the company I worked for a long time ago, we just stuck with xenon ion propulsion, which was very simple, and it tended to perform real well. Although the power supplies did tend to burn up after a while, but. So I don't know how easy it's going to be to fly the mission, but it turns out that from what our very skilled interns are doing right now, and the exploration of these toolkits, is that it may actually be kind of easier to plan this mission. I'm not sure exactly why. It's a very big surprise to me, but the solutions just seem to come like that. Now, it could well be that we've picked a very easy target this time, and I don't know if I should talk about which target it is, but it does seem to be extraordinarily...
You haven't even told me what target yet. You guys have been totally secretive.
The target is secretive. Why would we tell anybody? It's like when you were at Skunkworks and you refused to say anything. That's the target.
Has he told you?
All right. Well,
don't worry about it, Robyn.
Oh man,
I can say the target seems to be a very benevolent mission. Okay, as opposed to some of the others that we've tried to plan. So I'm not sure whether it's just this particular target is easy or whether the techniques are going to be easy.
Okay.
But we're getting very good preliminary results with these tools.
Well, that's the first good news here at 40 minutes.
Yeah. Well, it's going to change. I can guarantee you. You can't.
Don't worry, he's going to fuck you over soon.
But right now, this hour, things are looking good.
Okay.
All right. Okay. So that's how you're in trouble. But I can't say anything different right now because I don't have any other facts. So.
Apparently, I know I'm in trouble when I come to the podcast.
Yeah. So, but yeah, back to comms. We got off into mission planning, which is my other duty, which I love that one. But back to comms. Okay. So we talked about navigation.
Yep.
And so I think the hard part of this mission, Matt, is going to be we're going to actually try to land on this rock. Okay?
Yep.
And so just talking from a comms standpoint, one of the things we've done is we've decided that we're not going to be pointed at the Earth very well when we do that. We're going to land on some side of it, probably with 1 foot on a rock, and the antennas are going to be pointed in an awkward position. So what we have done for that okay, is there's a thing called margin, which is the amount of decibels that I hide in my back pocket.
Okay.
And we have upped that everywhere for these antennas that we're going to have to use on the landing, so that
We're overpowered.
You are not overpowered if you're going to be looking into the side of these antennas.
So let me get this straight. We're overpowered. We have too much propellant
And too big of antennas.
and too big of antennas. Yeah.
No, you don't have big enough antennas. No, you couldn't do that for me. So instead, you've got these.
Sounds like we just fixed our mass problem.
You've got these amplifiers all over the place, okay, soaking up watts, right?
Yeah,
Well,
yeah.
You could just as well have had a very nice big comm antenna like Voyager or something.
Yeah.
you know?
It's a little heavier.
I'd be happy.
So you
with
want
it.
an antenna that's basically the same weight as the
I would like something about a meter diameter if we could have that.
Let me see if I can go find a spare meter on the spacecraft
It's
You know,
literally
yeah.
bigger than the spacecraft.
You know, and
by a lot.
yeah, a gimbal would be nice too. You know.
Well, I have a gimbal.
Oh,
On the
the
thrusters.
antenna?
No, on the
No,
thruster.
I want another gimbal. Okay.
I got 2 gimbals.
Okay, really.
Well, the other one's on the thruster.
Well,
Other thruster.
I can remember one comm study I did. My buddies over here in that very building over there had a 6 kilogram gimbal. We could probably get that if you'd like that. 6 kilograms, you know.
6 kilogram gimbal?
Uh-huh,
sounds-
for a 1 meter antenna.
That sounds like a really expensive mass. Also, what do they do in that secretive Boeing building? Can you tell us?
Apparently, they built gimbals.
Yeah, they build
Really?
Or at least they
Really
use
heavy
gimbals.
I
gimbals.
shouldn't have said that.
They build gimbals on it? All right.
I don't know. How many degrees did they? How fast did they? Oh, no. Okay.
Well,
Yeah,
they
no.
could track.
All right, that tracks.
So far the takeaways are comms are really hard.
Yeah, well, it's just as hard as any engineering is. But, you know, I think that anytime you get to fighting nature, you know, you start to really have a lot of indefiniteness, and comms definitely fights nature.
Yep.
You know, and even when you get down to building the radios, I think one question we want to ask today is, do you build your own radios? And the answer is no. Okay, and there's 2 reasons for
Yeah.
that, because you're going to combat with nature for that.
Yep.
You're fighting ground planes. You know, you cut little notches out of things and it screws everything up. You know, that sort of thing. And the other thing is, it's hell to test these things. You know, you can't just radiate everywhere, and if you do radiate, it bounces all over the place. So you need big chambers, okay, big expensive chambers. You need screen rooms, et cetera, et cetera. And so the people that do this tend to get specialized.
Yeah.
You know, if you want to put that investment in plant, then you can build radios, but you have to be able to test them.
Yep.
And, you know, the other thing, too, is that you always have this problem with the range. Okay, you need to, we call it far field. You need to get out far enough away from the spacecraft so that the signal behaves the way it would, you know, in free space. So then you have to buy range time. It's kind of like engine testing. You're always stuck trying to get a range and find a suitable, you know, supplier of that, you know, with all the equipment and everything. It's, you know, and then you spend people out to the field, and
This
the
sounds like a
fog and the
service
cold,
we can
you know,
sell.
and everything. Yeah, I mean, you know, if you have that. But the last time I did a screen room, you know, it was like this copper vessel, and they told you to take off all the metal that you had on you and asked you if you had tattoos and things, kind of like getting an MRI, you know. So it's,
Wait, what the hell are you talking about? What happens at the towing building? So there's a giant copper room in building 2.
Remove your
Tattoos?
tattoos and then hip replacements is all I heard. Yeah.
yeah. You don't want a hip, you know, you don't want a metal hip.
Okay.
You don't want that, no. That sort of thing.
Wow. Okay.
It is. It's also useful if you're beyond having
Yep.
children too, as well.
Yep.
You know, that helps a little bit.
What the?
Wait, like take a step back. Hold on. What are you talking about? what does this room do?
RF testing, power.
Apparently, a lot of power.
So you just like shoot RF beams in a room of copper and
Well, you
kill your babies?
Well, you have to kind
baby
of have an
makers.
anechoic chamber, which will absorb all your RF. Okay, and that kind of gives you a far field effect. But
Okay.
when you start to screen these things, you know, I'm really talking about susceptibility and emissions testing. You know, where you're basically stressing the equipment to see if it survives.
Oh, the other way around.
Yeah,
Yeah,
that's-
you're trying to toast it.
That's-
Oh,
Got
that's
it.
what we
Okay.
call those EMI guys. Those
Yeah, yeah.
those fictitious people that just like carry around Tesla coils and zap shit. And
Yeah, this is like you're describing like a room-sized microwave.
But okay, so
Oven.
since we're telling war stories here,
It's literally all we do.
The way you're building the spacecraft right now, you're going to have an awful lot of like standing waves and other nasty stuff inside that spacecraft that's going to cause you some really weird effects, you know. It's going to get into your wires and your space. Your power supply is all of a sudden going to have telemetry on it, and vice versa. That's the sorts of things that can
On
happen.
our spacecraft now?
Yeah.
So we need to get a copper room.
You need to do EMI testing, and you need a screen room. Yes, you do.
Information that would have been useful yesterday.
And I don't know if you need the susceptibility testing. No one's going to attack you yet. But when you start to try to make claims on asteroids and stuff, the pirates are going to be out and they're going to try and get you. So you might want to think about susceptibility at that point too.
Maybe we're the pirates.
Yeah.
Well, Colin, thank you for thoroughly dousing all hope on Mission 3 throughout the entirety of this podcast.
I ran out of paper on generating new risks that need to be go evaluated.
Well,
My
I'm going to ask
goodness.
you one last question, and then we'll go into the mailbag, which will also be quick. What are you hopeful, or what are you excited by for Mission 3? You were here for Mission 2.
Yeah, give us some fucking positivity.
Give us.
Oh, God.
Let's end on a good note.
You said it the other day. All right. This is a quintessential exploring space. Okay. The hell with the platinum. I'll just say it. All right. I don't give a flip about platinum. Okay. We're in deep space, and who knows what we're going to find. Okay. It could be, we have the scientific community has postulated and thought about these asteroids, and they know about about these asteroids at this particular point. These objects are older than the Earth's formation. Okay?
Yes.
They have stuff on them from the very formation of the solar system. That, to me, is we're going to go there and land on one, and who knows what the heck we're going to find when we start drilling into.
Well, whatever we find, we are going to fry with lasers.
Yeah, sterilize it. We're going to sterilize it.
So we'll probably have no idea.
Yeah, and the other thing I like about the company is, even at an aerospace company, you don't get to sit around talking about things that are 9 billion years. And when you start to talk about, well, how did that platinum get on that asteroid? You're talking about, you're imagining and seriously talking about things about the formation of the solar system floating through a supernova and picking up platinum.
Yeah.
Okay, so you're talking about really big, huge cosmological things happening here, and going to go find it. Just really,
Man, we got to get Brian Cox in here.
this is the best thing about this company.
Is that the Queen drummer? No, that's the Queen guitar player.
Queen drummer?
Who's the Queen guitar player that got an astrophysics degree?
It's not Brian Cox.
I think it's Brian Cox.
No, it's just not Queen. Brian Cox is the right answer.
Okay, whatever. Some hair metal band where you did a lot of cocaine and then you
No, I'm
started
talking about the
studying
astrophysicist at CERN.
Okay.
Music at the spheres, I think is what they call that.
Mm.
Yeah.
We'll get them both on here.
Yeah.
Yep.
All right. We got one question for mailbag. It's a simple one.
Only one question because you curated it, or because only one person emailed us?
Just one person.
One person. Wow.
Just one person. Yeah.
Viewership going down.
We did get another email suggesting that we buy the domain astroforge.ai.
.ai.
Do you want to buy astroforge.ai?
I'm pretty sure we own astroforge.ai.
Oh,
I bought a whole bunch of
can check.
extensions.
Yeah.
And if I didn't, I'm not paying you for it. Whoever emailed us, I don't care.
All right. Well, the one question is, since we're a rideshare and we're on TLI, do we have any plans to go to Leo? They know there would be a trade-off on Delta V, but is there a world in which we just hop off a rocket in Leo and then just put our way out to deep space?
I mean, is there a world where we do that? Yes. Is there a world we do that with this size spacecraft? No.
I don't know. Colin just said we had way too much
Way too
propellant.
much fuel.
Yeah.
Well, we actually, in the early days, we tried to plan that.
We've modeled it multiple
Yeah,
times.
we modeled
Multiple
it
times with it.
yeah.
Womp, womp,
We
womp.
were going to fly out to the moon and come back around and do an Earth flyby.
Oh, that's a different thing. No. That was you trying to clock us around the moon. And I said,
No, that was hard to do. It was hard to do. But
Also-
theoretically, you'd have to do something like that. I mean, you have to do multiple flybys to get the energy.
Well, when we do, so we can do a spiral out trajectory from Earth,
Mm-hmm.
from Leo to do it. The problem is with EP thrusters, it will take upwards of one of the ones we did took 9.5 years.
Yeah.
It takes an exorbitant amount of time to spin us out that far with this low of thrust. Now, if we go to something like one of these OTV manufacturers, there's a whole bunch out there, but let's say we go on an impulse vehicle, that's a very different discussion, right? That's essentially a third stage of a rocket and can boost us out there, but your mass is going to be, how much does that vehicle weigh? I think 15 tons, maybe I'm wrong there. A lot of mass. So we're not doing it in a 200 kilogram spacecraft in any kind of time frame that makes sense today. unless we get one of these newfangled thrusters I get reached out to about every 2 months actually works one day.
Oh my!
All right. Well, I think we've effectively burned Robyn out. We're going to go give him some time to recover.
I'm going to need a day off.
Robyn's out tomorrow. All right. Thanks everybody for tuning into Roid Rage. We appreciate you, and thank you, Colin.
Sure. Bye.